My name is John Benitz. I am the Vice President of Professional Services at GrayMatter. I have over 37 years experience in the industrial automation. I worked with many different SCADAs and HMI systems since the old DOS days. And I have architected many SCADAs for various industrial verticals, and including water and wastewater systems. So who is GrayMatter? We are a consulting services first company. And we also help and deal with the implementation of the systems that are designed. And technology curation. Technology curation is, there is not one size fits all software out there. You have to take several different pieces and parts and pull them together to make the overall innovative best process system. So there is not just one all-inclusive solution. It's a set of the best parts and pieces, both hardware and software, that makes up the best overall system for the unique environments that are in water and wastewater. So, learning objective in this section, practical applications of the ANSI ISA 101 standard. So this standard was developed as a guide, not a hard, fast rule. So customizing this standard and adapting each case depending on the operators and the abilities at the utility. The most important step one of this process is the style guide. The style guide helps direct you on how to develop your application, the users and audience that's going to be using the system. As Prasad mentioned, you do not want to develop an all-encompassing one screen or a one-size-fits-all. The screens have to be developed for the audience. So the maintenance people versus the operations people versus the lab versus supervision or scheduling and planning are all looking at different detail information. The menu and ability to navigate is very different from site to site and from plant to plant, company to company. You'll see some examples of that I'll be showing you in a few slides. Control access. How do you want to be able to control the system and have access to that? Many different philosophies. You'll see a few of those and some examples that are coming up. It all comes down to making the information accountable. So everyone talks about data and having data on your screens, but data is only important if you can take action on that data. So creating screens that help operators visualize, but also gives you the accountability at a glance to be able to determine the information on the screen that requires action. That leads us into removing the clutter. In removing the clutter, several things come to mind. Organization, the layout, the amount of data, information that's on the screen that really has no relative action that is going to come from displaying it. As Haley mentioned, using grayscale and color to be able to enunciate information. So you'll see in some of these examples that are following that grayscale can be used to indicate whether an item is active or in standby or not available. But color, especially using red or yellow to indicate alarm and warning information, draws your attention much quicker to the item that needs action than just giving you green or red telling you that it's just on or off. So the first case study that we're looking at here is the region of Waterloo. Their challenge was they needed a standard between different utilities. Each operator had a different look and feel that they had to deal with. So moving from plant to plant, station to station, in different entities within their organization gave the operators a problem of having to see things differently at different places. Well, the solution, of course, style guide creation, making sure that the standards were set and all entities used the same look and feel standardization. Getting the operators involved in the standardization helped the operators be able to have their opinion on the best way to show information to them so they could react to it. The solution win? Faster exchange of information, correcting actions before they became major problems. So some examples of this. This screen shows a grayscale appearance with the alarms indicated by red being an alarm, yellow being a warning limit. And if you notice on the top left of the screen, they have a single button menu access. They chose to always return back to a home condition and drill down from there to their different levels of navigation. Towards the bottom of the screen, within the process area, you see two things highlighted. There is a pump that is gray and a pump that is white. The pump that is white is active and running. The one that is gray is available, but is not running at this time. On the bottom is two consistent areas that you go to look at for information. The left bottom is the control zone. This is where control appears whenever you click on an active device and wish to control it. On the right-hand side bottom is the KPI trend. This is your key indicators for this particular process and giving you a trend over time that you can control, seeing it at different time spans. Another example for Waterloo is this screen showing a process P&ID diagram. Some of the differences here is you see that the process flow is from left to right, top to bottom. There is no need to add additional information to the screen to be able to show you other things within the process that's not giving you actionable information. The other is, instead of showing tanks as a 3D image and showing a bar graph within them, that you have to kind of guess at where you are or where you've been, they are replaced with trend graphs so that you can see at a glance where you are, at what level, and where are you trending, up or down or stable. The other thing that is different, if you look at the oval circle on the vertical bar graph, we are showing, instead of just a number, we are showing you the range, the optimum range that you should normally be in, and the alarm limit ranges. If the dial indicator were to move out of the optimal range into an alarm or warning area, that bar would turn blue or red to immediately indicate a warning or alarm. The next case study is Palm Beach County. Their challenge is a little different. They had a lack of commonality, both in terminology and visualization. So everyone was calling different items different things. So moving from plant to plant and across different areas of the site and facilities, both terminology and the way it was visualized were different, which caused problems both across their water, wastewater, and lift station control areas. The solution? Upgrading the SCADA and HMI system and its infrastructure at all 8 major facilities. This is in progress right now, and over the 6-month period in 2019, this will include training the operators within the ANSI ISA 101 standard and the latest iFIX and high performance graphics. So far during the implementation, solution wins have been the operators are more accepting to the various levels of experience, creating the style and standard presentation documents, using templates so that the images for each control area are identical and you can predict and know how you're going to control them and use them, and using the high performance graphics. So on to some examples. On this example, you see they are using the grayscale methods, and on the far left side, their menu is driven more of a hierarchical menu access area, where the top section is plant-wide, the center section is within that site specifically, and the bottom section controls the views and acknowledges and deals with alarming information. Right up front and center is the process area that has a consistent look and feel of flow from left to right, top to bottom, and giving key indicators using the same style vertical bar graphs to indicate normal operation and alarming limits, tanks and other process levels shown as a graphical representation, and information grouped together to show a particular area of a functionality. One key difference here is on the bottom of this one, we have an alarm summary showing you the current alarms within this site and key indicator trends on the right-hand side. Also, if you notice in the control areas within the screen, you see a small gear which indicates our control area. So on this screen, we see those control areas being accessed, and each area has its entire control access function displayed, so the operator can immediately control the entire aspects of this area of the plant. We are also showing using the grayscale white and gray to indicate whether an item is active or it's available. Our next use case is Delco Water. A little different challenge here. They're taking in lots of detail, but they had no ability to act upon it. Their screens were very busy, had a lot of different colors, had a lot of 3D active components on them. So there was lots of information, but very little ability to act upon it quickly. The solution, creating actionable data by implementing the iFIX and Historian and adopting the ISA 101. This system is in the final stages of testing, and the solution wins here is the operators can now go from site to site, see problems consistently on the same style of screens, and be able to see at a glance actionable information and be able to act upon it. A couple examples here is being able to use analytics and show graphically areas of how the process is trending, being able to show information in grayscale, reducing the clutter. They have chose to use a muted green to be able to show that the item is on or running. And if it is an alarm, it'll show up in red or yellow. In addition, if you notice one change in this screen is that the control access area is at the bottom of the screen, showing all parameters that relate to this screen and is visual all the time. Unless the operator has permission based on their login security, then this is view only and does not give them action. In addition to that, they also use a home button to do a flat style navigation, coming back to an upper level and choosing the system in which they're going into. Another change is when they have a specific control area, such as chemical controls, They are putting the key indicators of both the process values and equipment status on the screen, along with the control functionality of each of those areas. So in summary, what this shows you is that using the standard will create consistency. Creating a style guide both creates that consistency of constant look and feel, definitions, and descriptions of items, both for internal use and external use. The other thing that you've noticed here is that the methods being used have flexibility. This standard is written such as a guideline, having the users keep to a consistent, non-standard access view, but not limiting you to a specific way of doing it, as long as it is consistent all the way across. Menu methods. They're based on operational flow and requirements. So you've seen some changes there. Access control, the same consistent appearance and capability. Data, actionable data, at-a-glance information to be able to react. Variations within the standard is acceptable as long as the company creates this consistent use.
Thanks for watching. If you found this video insightful, click here to watch the next video and learn how GE Vernova is at the forefront of tackling challenges in the water and wastewater industry.